Hello everybody, welcome back to another video, and in this video we'll be looking at the integral of e to the 2x sine of 3x using integration by parts. So this is a pretty fun problem and a useful problem to work on if you're learning the integration by parts technique and you're encountering repeated integrals, as this is one of those cases. And the first thing that we want to establish with these kinds of questions is we want to set some variable I, for instance, being equal to this integral. Now let's get started, and I'll be using the DI setup, which is the exact same thing as just the regular or traditional integration by parts, but it's just a more visual way of approaching the integrals and derivatives and seeing how the products work. So here we have the derivative and what we have to integrate, and here we have the signs. So let's choose to take the derivative of sine of 3x. I will tell you here that it does not actually matter which one you choose to integrate and which one you choose to differentiate, as both of them do work, and I will leave you to try integrating sine of 3x and seeing if you still get the same answer. So now let's integrate e to the 2x, and what we notice here first of all is that the product of row is always our integral. So this is our original integral, as the product of this row will give us this. So anyways, now what we do is we compute the derivatives and the integrals of the respective functions. So let's take the derivative of sine of 3x. So we know the derivative of sine of 3x is going to be 3 sine cosine of 3x. And why is that the case? Because when you take the derivative of sine of 3x, we have a function of a function, and we know that if we have that, we have to use the chain rule. So for the chain rule, we take the derivative of the outside function. We know the derivative of sine is cosine. Then we keep the inside. Then because this is a function, we have to multiply by the derivative of the inside function. The derivative of 3x is 3, so you multiply by 3. So if you have some sine of ax or cosine of ax, it's just going to be a times the derivative of whatever that sine or cosine is, which is going to be cosine or negative sine. So this first thing will be 3 cosine of 3x. Now, when we take the integral of e to the 2x, we use the exact same thing, except we use the reverse chain rule, which is a u sub. So if you're integrating e to the 2x, you would set u to be 2x, and then you would see that dx is du by 2, and this is just a quick speed run. This should be just a recap. You take the 1/2 out, you have e to the u is e to the u, so you just have e to the 2x divided by 2, and in a more general case, if you're integrating e to the ax dx, that's just e to the ax over a. So what we have here is just e to the 2x divided by 2. So e to the 2x, and then let's just put a 1/2 here. Now, what we see is that we can't get much so far, because first thing we do, we take the product of the diagonals. Okay, that's fine. But then our last row is going to be an integral, and we have to take the integral now of 3 cosine 3x. Let's just say we take out all of the constant multiples. We have to integrate e to the 2x cosine of 3x. That doesn't help us yet. So let's do one more layer. And this is why the DS setup is so nice, because we just add another plus here. These are alternating signs, and then we can just do the same thing. So let's integrate 1/2 of e to the 2x. So that will just give us, of course, 1/4 of e to the 2x, because now we have 1/2 divided by 2. And now taking the derivative of 3 cosine 3x, well, that's going to be 9. And then what is the derivative of cosine? That's negative sine. So we actually have a negative 9 cosine of 3x. And wait, that was a joke. It's negative 9 sine of 3x. The derivative of cosine is negative sine, just to be clear. So what we can do now is we can actually now take this diagonal and then take this as an integral, and we'll see that something nice works out here. So this is our integral. So what do we do now? So we have the product of the diagonals. So the first thing we have is 1/2 e to the 2x sine of 3x. Then we have a minus here, so we subtract. Here we have a 3 multiplied by a 1/4. So that is going to give us 3/4 of, and then we have e to the 2x, and then here we have cosine of 3x. And then what do we have here? We have a plus, and then here we have a minus. So what we can do is we can take this minus out of the integral and see that here we have a minus, and then here we have the constant multiple of 9 and 1/4. So that is going to give us 9/4 on the outside that we can take out, and here we just have the integral, and let's just take the functions now. That's e to the 2x, and then we have a sine of 3x dx. Just running out of space there. So this is all good so far, and what we notice that is pretty cool is that our original integral I is equal to this entire expression right here. And what we also notice is that this integral happens to be exactly what I is, because I is defined to be the integral of e to the 2x sine of 3x, and this is exactly what we have here, and this is the repeated integral case. So what we do is we treat this as a regular equation where we have I is equal to, and now we have 1/2 e to the 2x sine of 3x minus, here we have 3/4 of e to the 2x cosine of 3x. And here, that integral is our I. So we have minus 9/4 of I. Now we treat this once again as a regular equation. So how do we solve for I here? Well, we just have to add now 9/4 of I to see that this minus 1/4 and this plus 9/4 of I will cancel out. So here we have 1I plus 9/4 of I. So that's the same thing as 4I over 4 plus 9I over 4, which is just 13I over 4. So we have 13I over 4, and that's equal to this entire thing right here. And we've gotten rid of the minus 9/4 of I. So here we have a 1/2 e to the 2x sine of 3x minus 3/4 e to the 2x cosine of 3x. And this is what we have to evaluate. Now, all we have to do, remember, our original goal is to find I. And I is the integral of e to the 2x cosine of 3x. That is our original, or sine of 3x actually. That is our original thing that we want to find. So how do we find that? Well, we just isolate I. And how do we isolate I? We have 13 over 4, let's say x equal to y. How do we isolate x? Well, we just multiply both sides by the reciprocal of this multiple, which happens to be 4 over 13. We'll see that this and this cancel, and you're just left with 4 over 13y. So what we need to do here is we need to multiply this entire expression by, and let's just move this as well over, let's just move this, and we see that we don't really need this. We know that we want I. So here we multiply by 4 over 13. So what we see when we multiply by 4 over 13, this will cancel. And you're just left with I is equal to, so that's good. And then we have a 4. And here we have everything in brackets. We have 1/2 e to the 2x sine of 3x minus 3/4 e to the 2x cosine of 3x, close this big bracket, and we are dividing all of that by 13. And this is essentially our answer. However, we can do some more simplifying, because what we can do is we can distribute this 4 to each term in the bracket, and we'll first of all see that this 4 and this 2 will cancel to make 2, and this 4 and this 4 will cancel to just leave you with a 3. So what we have here is that I, which is equal to the integral of e to the 2x cosine, wait, I keep on saying cosine, but it's sine of 3x dx, that is equal to, and then here's our answer. We have 2e to the 2x sine of 3x minus, and then here we just have a 3e to the 2x cosine of 3x, all divided by, and just make that a bit nicer, all divided by 13, put a plus c, and we are basically done. So this is our answer to this problem. So that was it for today's video, and thank you for watching.